So today we're going to be looking at the quiz for the, or the study guide rather, for the exponent quiz coming up in 8th grade. There's a lot of kind of nuance in this. There's a lot of little details you have to be aware of, but a lot of it can be generalized into some kind of major rules. So the first three problems we have here are basically simplifying things with exponents. So if you have a big mess of things where there's a lot of exponents and a lot of variables, simplifying is basically kind of cutting that down so there's as few of things as possible, so you look at the problem a little bit nicer way. And basically there's three main rules to follow, about three. So the first thing is that whenever you have two exponents that have the same base and that are divided to each other, you can just subtract them instead. So for example, if I have x over or x to the fifth over x to the third, I can make that into x to the 5 minus 3, which is just x squared. So that's the first rule, is that when you divide bases that have the same exponents, you can simply subtract the exponents and get your new answer. The other one's multiplication. If I have x to the fifth times x to the third, I can add the exponents together and make this x to the 5 plus 3, or just simply x to the eighth. So that's the second rule, is the product rule. If you multiply bases with the same exponents, you can add the exponents and get your new answer that way. And the last rule is that, well, the last rule is kind of two rules in one, is that if I have like x to the third and to the fifth, so x to the third and then to the fifth, I can simply multiply my exponents and make it x to the 15th. So I'm not changing anything, I'm just changing the way it looks, so it looks nicer, because this is a little bit nicer to read than that. And the same happens with roots, except that you do the reverse. So for example, if I have the square root of x to the eighth, the square root means divide the exponent by 2. So this is basically x to the 8 divided by 2, which is just x to the fourth. So square rooting means divide the exponent by 2, essentially. So using these rules, we're going to simplify these problems down to a little bit nicer form. So if you look at the first one here, the bottom one has an exponent on exponents. I'm going to work with this first to get rid of the parentheses. So I'm going to keep the top the same for now. 9, a to the fourth, b to the 10th, over negative 3. So this, remember, if you have an exponent on exponents, you multiply them. And if you have multiple things in here, you multiply them all by the outside exponent. So this 2 is going to multiply to the 3 and to the 7. So 7 times 2 is 14, so this will be a to the 14th. And 3 times 2 is 6, so it'd be b to the 6. And then now what I'm going to do is I'm going to use my rules. Now the first thing I'm going to do is actually take care of the numbers. So this right here, 9 divided by negative 3. Because remember, this is the division bar. So I'm just going to do all three of these divisions separately. 9 divided by negative 3 is negative 3. So that's done. Now this next one here, if I can try, is a to the fourth divided by a to the 14th. Well, if I divide the same base with different exponents, I'm going to subtract them. Top minus bottom, always in that order. So 4 minus 14 is going to give me negative 10. And then here, b to the 10th divided by b to the 6th, I'm going to subtract the exponents again. 10 minus 6 would be b to the 4th. Now this is almost done. The reason I say almost is because normally we do not want our answer to have a negative exponent. So this is a problem right here, negative 10. So the way you change this into a positive is you basically flip it from the top to the bottom. Because remember, this is basically all this over 1. Remember, I can put anything over 1 if I want to. So in order to make this part positive, I'm going to flip it and put it on bottom. So it'll be negative 3 b to the 4th over a to the positive 10th. And that would be my final answer, because that has all of the reduced terms, and there's no negative exponent. I can have a negative number, I just can't have a negative exponent. And again, this is a lot easier to look at than this, which is why it's called simplifying. For number 2, again, the square root means to divide the exponents by 2. Now, you might think, well, we'll get to the 25 in a second. Let's work without the numbers. So we have the square root of 25. I'm going to do that later. This is k to the 8th. So the square root of k to the 8th, again, divide the exponent by 2, and you get k to the 4th. n to the second. So divide the exponent by 2 and you just get n. And z to the negative 6. Well, again, divide the exponent by 2 and you get z to the negative 3. And then we know that the square root of 25 is just 5 itself. That's just a number. So I'm going to write it as 5 z to the negative third n k to the fourth. And again, I do not want negative exponents, so I'm going to flip that z to be on bottom. So it'd be 5n k to the fourth over z to the third. Again, no more square roots, a lot easier to look at. On this one, I'm going to start the same way I did number 1. I have to distribute this 12 and multiply it to all the inside exponents, not the inside numbers, but the inside exponents. So this 6, remember, this 6, if you don't see it, has an invisible power of 1. Same for this y. If you don't see it, there's an invisible power of 1. So 12 times 1 would give me 6 to the 12th. 12 times 7 would give me x to the 84. And then 12 times 1 again will give me y to the 12th. And then on bottom, you have what you have. So x to the negative second and y to the 20th. And then now we go about our division. So there's nothing to divide with the 6 to the 12th. There's no number down here to divide with the 6. So I'm going to keep it as 6 to the 12th. Now be careful here. This is 84 minus negative 2. 84 minus negative 2, which makes it into a plus, which makes it 86. So it'd be x to the 86. And then here we'd have y to the negative 8, because 12 minus 20 is a negative 8. Again, I don't want negative exponents, so I'm going to do the same thing I did in the last problems. I'm going to put that negative 8 on bottom, along with the y it's attached to. And here we go. That'd be my final answer. Again, I slap the negative exponent on the bottom to make it into a positive. The reason why that happens, we covered in class. I don't want to get into it now to kind of lessen the length of the video. But that's how you get rid of a negative exponent, is you take it and you put it on bottom, again, along with its base. So you can't just put the negative 8 on bottom. You have to put it there along with the y. Now, the next ones require you to know the exponential function formula or setup. So the exponential function formula, or an exponential function, essentially looks like this. Y equals a times b to the x, where x is usually the time. So that's how long something takes, hours, years, seconds, minutes. And then y is usually the number of something you have left or that you will have or stuff like that. So if you're counting the number of chickens or the population, which is the number of people, or the number of crops, like that, that's going to be your y. A is what we call the IV, the initial value or the starting amount. So A is how much of the thing you start with, and then B is tricky. B depends on whether it's a percent increase or decrease. So if it's an increase, if you're going up, if it's an increase, what B is 1 plus the percent. So B is 1 plus the percent if you're going up. If you're decreasing, so if you're going down, then B is 1 minus the percent because you're going down. So B depends on whether you're going up or down, whether you're increasing or decreasing. Everything else is consistent. So if we look at number 4, the population is currently 3,500. So that's my A. That's my initial value currently. Be on the lookout for the word currently because that's going to clue you in that's your A. Due to living conditions, the population is decreasing by 6%. Now I have to be careful here because I don't want to use 6. 6 as a decimal is, or 6% rather, is 0.06. So this is the number I'm going to use as my percent. So these mean the decimal form of the percent. So A times B. Now I am decreasing. So B is 1 minus the percent. Oops, 0.6. What will the population of the village be in 25 years? Well, 25 years is a time, so it'll be 25, and that's going to be equal to y, or the number I have left. So I'm just going to simply find out what is this. Well, that requires me to do some work here. So I'm going to do the parentheses first. So I'm going to keep the 3,500. I'm going to do 1 minus 0.06, which gives me 0.94 to the 25th. Now, remember, exponents come first, so it's going to be this part first. 0.94 to the 25th first, and then you're going to times that by 3,500, and that will give you your population of 745.19, or if we just round it off, approximately 745 people. So that's how the population of the village will be in 25 years, assuming they decrease at 6% a year. Again, the b value was being subtracted because we're decreasing, and the percent is the percent as a decimal like it normally is. Here we have Sally invests $300 into an account that earns 5% compound interest every year, compounded annually. How much will she have at the end of 20 years? So this is a compound interest formula, and it's very similar to the one we just did, but it has its own sort of formula spin-off. So it looks very similar, it's just a little bit different. The way the compound interest formula goes is A, so the amount you have. So this is the total amount you will get, interest plus what you have already. So the amount you have is equal to P, which is the principal. So this is kind of your IV. That's how much you start with. That's the amount of money you start with, times 1 plus R, and the R here is the percent as a decimal, divided by N. Now what's N? Well, N is how many times it's compounded or taken a year. How many times the interest rate is actually applied a year. If it's applied annually, then the N is just 1. If it's applied biannually, then the N is 2. If it's applied quarterly, the N is 4, and so on. So the N is simply how many times it's compounded, and what compounded means in this case is basically how many times they actually go and apply the interest to your account. How many times are they going into your account and adding that 5% increase? In this case, it's just annually, so it's just once. And then we have the N again, so it's going to be all this to the NT, where T, of course, is time. And T is time in years. It has to be, again, years. So the way this would look is A equals $300 into the account to start with. That's my B, or sorry, my initial value, my P, times 1 plus my interest rate, which is 5%. So I'm going to put it as 0.05 because it's an R decimal, over 1. I don't really need the 1 there, but I'm going to put it just to emphasis, times 1, and it's going to be 20 years, so to the 20. And then just go ahead and work it through. So I'm going to work the inside first. So 0.05 divided by 1 is 0.05. 1 plus 0.05 is 1.05. And then 20 times 1 is 20. So I'm just going to plug that in. And again, do the parentheses first, or the exponent first. So it's going to be 1.05 to the 21st. Figure out what that is. And then you're going to times that to 300. And you get 795.99 if you end up rounding. So that's actually 9989, but we're going to round it to the nearest decimal, or to the nearest cent, so it'll be $0.99. So about $796 at the end of 20 years. So it's a little bit of a different formula. It still has the same bearings because P is kind of like your A, and this big chunk here is kind of like your B, and then this little chunk here is kind of like your X. So it's in the same formation. It's just a little bit extra with that N in there. So remember, N is how many times they tell you it's compounded. So annually means 1, biannually means 2, quarterly means 4, semi also means 2, so they say semi, that also means 2. Triannually obviously means 3, and so on. The number of trees on a tree farm increases by 35%. If there are 400 trees, how many will there be in 7 years? So again, this is back to being a normal exponential equation form because there's no compound interest or anything. So we're back to the y equals a times b to the x deal. So y equals my initial amount, so 400 trees currently, so 400, times 1. Now we are increasing, so 1 plus 0.35. And then time in years is 7. So once again, I'm going to do my parentheses first. So this would be 1.35 to the 7. Again, doing my parentheses first, so 1.35 to the 7. Do my exponents first, rather. And then times 400, which gives me 3,268.8 0.86. If we round that to the nearest tree, that'd be about 3,269. That's how many trees there are in the tree farm. So if they say compound interest, that's when you use that special formula. If it's just percent increase or percent decrease, that's when you use this equation formula, or the exponential equation formula. Now the last one is called a geometric sequence. And so what that is basically you have a list of numbers and you want to find out what's the rule, and then you're going to write two different versions of that rule. So for example, here we go from 20 to 10, 10 to 5, 5 to 2.5, and down on. So figure out what's happening each time. Well, 20 times a half is 10. 10 times a half is 5. 5 times a half is 2.5. So we're multiplying by a half each time. This is what's called R, or otherwise known as the common ratio. So the common ratio is just another way of saying what you're multiplying by each time. You could also say dividing by, but the formulas are set up for multiplication. So if you have like divide by 2, just change it to times a half. Or divide by 3, change it to times a third, and so on. So we want the recursive, so I'll put that here, recursive and explicit. Whoops, explicit. So there's two different ways of writing this rule. Instead of just saying multiply each term by half, there's two different math ways of writing it. The recursive way is a little bit easier. The recursive way looks like this. A sub n is equal to r times a sub n minus 1. So what a sub n is kind of like your y. This is the number that you want. So this is the number in the nth spot. So a is the number, n is the spot. So for example, this is my first spot, second spot, third spot, fourth spot. So these 1, 2, 3, 4, these are my n's. And the numbers down here, 20, 10, 5, and 2.5, those are my a. So if I said a sub 3, that would be the number in the third spot. So third spot, number's 5, so this would be 5. So a sub n is the number in the nth spot. So if you want the nth number, what you do is you take your r, your common ratio, times, and this is a sub n minus 1. So what this means right here is basically the number in the spot before. So n minus 1, in this case, is the number in the previous spot. That's what n minus 1 means, is previous spot. And so a sub n minus 1 is the number in the previous spot. So the recursive formula here would look like a sub n, or the number that you want, the nth number, is equal to 1/2, which is our common ratio, times the number in the spot before it. So it's basically a math way of saying what we would in words. We would say, what's the rule here? Well, you take the previous number and you times it by a half to get the next number. That's exactly what this says, just in math terms. To get the next number, you take the previous number, which is this, and you multiply it by a half. So that's how we end up with the recursive formula. So again, this is just saying what you normally would in words. The explicit is a little bit different. The explicit is basically a way to get any number you want in the sequence. So if I wanted the 100th number or the 1000th number, how do I get that number without knowing what came before? Like for example, if I want to look at the sequence and know what's the 10th number, well, I don't want to work out all the way to the 9th number just to figure out what the 10th one is. I just want to get to the 10th number right away. What rule would I do that? And the rule for the explicit like that is as follows. A sub n, again, the number that you want, is equal to a sub n minus 1 times r, whoops, sorry, messed up there. A little ahead of myself. It's just a sub 1 times r to the n minus 1. So what does this mean? Again, this says to get the number that you want. Again, a sub n is the number that we want. It's kind of like our y. To get the number that you want, what you do is you take the first number, a sub 1, so it stands for first number. Take the first number and times it by your common ratio taken to the n minus 1 power. So what this one here means in this case is, again, the spot before power. So if you want the 10th number, you're going to want to multiply a sub 1 by r 9 times. If I want the 10th number, I multiply it 9 times. And you can kind of see how that works. Like, for example, if I want the 4th number, how many times do I multiply 20 by a half? Well, I do 20 times a half, then times a half, then times a half. So it takes me 3 multiplications to get to 4. And it takes me 2 multiplications to get to 3. And it takes me 1 multiplication to get to 2. So if I want to get to 10, I'm going to have to do 9 different multiplications. That's why I have an n minus 1. If you want the 100th term, you have to times by r 99 times to get there. So in our formula, this would look like a sub n, again, it's like our y, is equal to our first number, which is 20, times our common ratio, which is 1/2, times n minus 1. So again, n is just the number that you want. So what you're getting is sort of the beginnings of a problem. You're saying, okay, here's the formula to get whatever number you want. You tell me what number you want. I can use this formula to get you to that plus spot. So if I wanted the 100th number, I would say, okay, find me a sub 100. Find me the 100th number. What I would do is I would take 20 times a half to 100 minus 1. So I would do 100 times 1 is 99. I would do 1/2 to the 99th power, times it by 20, and that would give me the 100th number. I wouldn't have to do this 99 times. I would already know what it is given the explicit rule here. So that's all these rules are. All these rules are a different way of saying what the pattern is in a mathematical way rather than a verbal way. Instead of saying you can take each number and times it by a half to get to the next number, you can just say it with these formulas here and achieve the same result. So again, a lot of different parts of this. They're all kind of linked into this exponent theme, but there's a lot of different moving parts between the first few problems and the last one here. So make sure you understand both and study both, and you should be okay. That wraps this one up. Hope you enjoy the video. Have a good day.